Cool. Hi, everyone. Welcome to today's webinar. We've got GCSE Maths today with our lovely tutor, Molly. Welcome if this is your first time joining us, and welcome back if you've joined us for one of these sessions before. So today's session, if you haven't met her yet, will be led by our brilliant tutor, Molly. Molly is one of our top My Tutor tutors. She's completed lots of lessons with us, so she'll be leading the session today. As usual, the session will be lasting 1 hour. We've got GCSE Maths sessions running every day this week at 12:15, and we've also got some GCSE Physics sessions running later in the day at 2 p.m. So we'd love to see you there if you want to join us for those sessions as well. As usual, you can ask questions via the chat function, and myself and Molly will do our best to answer those during the session, and then we'll also have some time for a Q&A at the end. So feel free to ask any questions during or at the end of the session, and we'll be able to answer those for you. And also all these lessons are recorded, so you'll be able to watch those back. And if you've missed any past sessions, you can watch those as well, so that's great. So today's session is GCSE Maths, and it's on expressions and formulae, linear equations. So Molly, if you're ready to go, should we kick things off?
Yeah, cool. Hi everybody, I'm Molly, and you've already heard me introduced probably many times if you've come to all of these. So we'll dive straight in, but yeah, feel free to jump into the chat at any point, say if I'm going too fast, too slow, anything like that. And any quick questions I can answer as we're going. So cool. So today, yeah, it's going to be about expressions, formulae, and linear equations. So to start off with, we're going to do a bit of work on the difference between all of these things, because expressions, formulae, equations are probably words that you've heard tossed around quite a bit, but potentially don't know the actual difference between them. So an equation is something that can be solved, something with just one unknown variable. So for example, 2x plus 3 equals 7. That's something that we can solve. We can find out from that x equals 2. That makes it an equation, something equated to something. An expression doesn't have an equal sign. It's just a way of representing something. So for example, an expression for the area of this rectangle would be 4x times 6y, or 24xy. That's just an expression. We don't know what that's equal to. It's not an equation. It's just a way of representing the information in a short, condensed way. And then finally, a formula is one with multiple unknowns where we plug in the values. So you've probably used a lot of formulas before. For example, Pythagoras, that's a formula. So a squared plus b squared equals c squared. We're not trying to solve anything here unless we have the values of a and b, or b and c, and we're trying to find one. So for example, also the sine rule or the cosine rule, or lots of different things, Suvat equations, if you've seen them, maybe in physics, maybe in mechanics. All of these are a formula. So we've got letters representing things that we're then going to plug in. So hopefully that makes sense. Let me just make sure that I can get the chat up. Cool. Oh, someone said, what is an identity? That's a great question. An identity is a bit of a tricky one to define. An identity seems really, really similar to either an equation or a formula. So I'll give you an example of one that would be here. Identity would be, yeah, I mean, sine squared x plus cos squared x equals 1. So this isn't an equation because we're not trying to solve x, because this is true for every x. So we're not trying to find out for which x this is true. This just always is true. It's not an expression because we have equated it to something. And it's not a formula because we're not trying to plug values in. If we plug a value of x in, well, yeah, it's going to be true. That's what this is saying. So an identity, we normally write with an equals with 3 lines. So an equals like that. And the reason is because what it means is this is an alternative way of representing this. It's kind of like saying that this is equal to this. It is. But an identity is just saying this is exactly the same as this. Hopefully that makes sense. That's quite a tricky one to understand kind of the nuance of why it's like that. So hopefully that makes sense. Okay, yeah, that's true. Someone else has said, if we say something like 2x plus 3 is equivalent to, maybe rather than equals, 2x plus 6. Yeah, thank you to whoever pointed that out. So as you can see, this is true for every single x. They're just equivalent ways of writing the same thing. And that's what an identity is. And that's why these are called trig identities, because it's not a formula. We're not trying to show anything by it. So hopefully that makes sense. Awesome, thank you. Cool. So I've got a little mini activity for kind of just drilling that in, working out which is which. So we've got a big group of things here, and we want to determine whether or not these are expressions, formulae, or equations. So the way that I'm going to do it, rather than dragging or dropping anything, I'm just going to color code them. So we'll start off by searching through and looking for all of the, let's look for all the expressions. Now these are easy to spot because they won't have an equal sign. So for example, 2a plus b. That's an expression because it's just a way of representing something. We don't know what it equals yet. ABC. That's an expression. It's just a way of expressing 3 variables multiplied together. Similarly, x plus 2y, 2a minus 5b, x plus x plus x, a plus bc, 2x plus 4, 3 lots of a minus 5. And those are all the expressions there. So just let me know if any of those don't make sense. Someone said, what is the difference between the 2 equal signs? So I guess you mean like a normal one and the identity one. It's a really difficult one to explain. In a simpler way as I can put it, the equal sign is basically saying, this is equal to this. Oh, we have something to solve here. For example, here, saying 2x plus 3 is equal to 7. It's like, oh, okay, so we can do some rearranging and solve. Whereas when we say this means more like is equivalent to. So we're saying 2 lots of x plus 3 is equivalent to 2x plus 6. Because it is, there's nothing to solve. There's no point in moving something to the other side of the brackets because that's true for every x. We've just expanded. So it's quite a nuanced definition. And don't worry, at GCSE level and even at A level, you won't be penalised for using the wrong equals, but it is a really good one to understand, especially if you see it in a paper or anything like that. So hopefully that makes a bit of sense. Will this come up in GCSE Maths exam? No, you'll need to know the difference between them. But yeah, the 3 lines is equivalent to, basically. And although it won't come up, as in what do these 3 lines mean, it might say you have the identity this, and it's better to know what it means rather than being thrown off by the 3 lines. So moving on with this one, we'll have a look for the equations now. So the equations are one with just one unknown, where it's going to be something that we can solve. So these are things, for example, here. The only thing that we don't know here is b, and we know what it's equal to, so we can work out what b is equal to. Again here, we can just multiply both sides by 5 and find that x equals 30. Here, the only unknown is x. Here, the only unknown is x. Now here, even though x occurs twice, it's the only unknown. That's the same x. So we can subtract x from both sides and make this x equals minus 5. So do that, and then finally, this one's an equation. And then, well, we know because we're looking for the 3 that all of the final ones are going to be formulae. That's the plural of formula. Some Latin thing, I don't know why. But we can see where these are going to be. So this here, this is the formula for a straight line. Y equals mx plus c. You just substitute in the gradient and the y-intercept, and you've got something. Here, this is a formula that's saying the area of a circle is pi times the radius squared. So you substitute in the radius and you get out the area. V equals u plus at, that's one of the Suvat equations for velocity. Don't worry if you don't know that, that's not really maths. Although it might be in mechanics. I'm not sure about the specs actually. Here's Pythagoras theorem, like I mentioned before. Here's a speed, distance, time. And here is one, circumference equals the pi times the diameter. So hopefully this kind of makes sense why each of these are categorized as they are. Sorry, there's just some questions. Let me have a look. So someone said, is it possible for you to explain what sine tan cos is actually for? That's probably for a different topic. So I only used it as an example of an identity, but we will come to that in a further week, I would assume, at some point. So I'll come to that at a different time. What's the difference between a formula and an equation? The difference between a formula and equation is that an equation will only have one unknown. It's something that you can solve. So if we look here at, for example, let's take a look at this equation. We can take a look at this and we can work out what B is. And there's only one possibility for B, it's going to be 0. You can fiddle around with it and work that out yourself. However, if we look at a formula, for example, here, A equals pi r squared. We can't work out A or R without substituting something in, but we can say that the area is equal to, the area of a circle with radius 3 is equal to 9 pi, pi times 3 squared. And the area of a circle with radius 4 is 16 pi, and so on. So this is something that's true for every pair A and R, but we have to substitute something in to actually find what the solution is going to be. So in simple terms, the difference is that an equation is solvable. It only has one unknown. There can be an unlimited number of unknowns for expressions. For example, we can see here with V equals U plus AT, there's 4 unknowns. Basically, as long as it's more than 1. Hopefully that makes sense. Yeah, cool. So hopefully that makes sense. That's for, I don't know if you were asking about expressions or formula, but either of them can have unlimited unknowns. Hopefully this will make more sense. We're going to go over some expression-related questions, some formula-related questions, some equation-related questions. So hopefully seeing the differences between the questions, you'll get to know the differences between them as well. So we're going to start off by having a quick look at expressions. Now, sometimes we need to form an expression to work out how to represent some bit of information. These could then be solved in the future if necessary. So for example, an expression like we had before for the area of a rectangle, then if we suddenly get information about that area, then we can turn it into an equation. So let me just grab some questions from here. So here we go. So, for example, here, John is n years old, Kim is 3 years younger than John, and Vanessa is half of Kim's age. So write an expression for each person's age. So we want to write an expression for John, Kim, and for Vanessa. Well, John, we've been told, is n years old. And then we just look at the information as we're reading it. So Kim is 3 years younger than John. That means Kim is whatever John's age is minus 3. So if John's 14, then Kim is 11. And Vanessa is half of Kim's age. So what we do is we take Kim's age the expression that we have for Kim's age, and we half it. We divide it by 2. So an expression for Vanessa's age is n minus 3 divided by 2. Hopefully that makes sense there. And if you came yesterday, we were actually forming and solving equations. Now what we've kind of done here is formed an expression that we could then use to make an equation. So I'll show you what I mean. So say there was a part 2 of this question that said, Vanessa is 12. How old is John? Well, now we take the expression that we have and we set it equal to 12, making it an equation. So that's all an equation is that it's an expression that's been equated to something. So now we know that this n minus 3 divided by 2 is equal to 12. And now we can use some of our skills from yesterday's session to solve this. So we multiply by 2. So n minus 3 equals 24. And then add 3 to both sides. So n equals 27. And that's John's age. John is 27 if Vanessa is 12. So hopefully that makes sense. Yep, a lot of people got that. 7, cool. Awesome, well done guys. So that's how we form expressions. I'll see if there is another one that we want to go over. Yeah, so for example, this here. So a rectangle has a width of x centimeters and the height is 3 centimeters less than the width. Write an expression for the perimeter. So you know that the height is 3 centimeters less than the width. That was a really badly drawn arrow, sorry. So similarly to before, you take the width and we subtract those 3 centimeters that we have. And now we just use that to work out what the perimeter will be. Well, how do we find the perimeter? We add together all of the side lengths. So we have this x at the top, add x minus 3, add that x along the bottom, and then add the other x minus 3 here. Because we know that because it's a rectangle, this one will also be x, and this one will also be x minus 3. And then we can simplify this, so we can combine all of the x's together. So that's 4x. And then we can combine all of the numbers. So we have a minus 3 here and a minus 3 here. So 4x minus 6. And what this means is that if somebody comes along and says, oh, Molly, the width of this rectangle is 5 centimeters. X is equal to 5, you know, as frequently happens in my life. Then what we can do is we can plug x into our new expression and say, oh, okay, so the perimeter is going to be 4 times 5 minus 6. So our perimeter is 14. And if someone comes along and says, oh, I've got a rectangle that behaves the same, but the width of this one is actually 11. Well, then we know that we can do exactly the same thing because we have a general expression for the perimeter of a rectangle like this. So we can go, oh, okay, 4 times 11, 44, minus 6 is 38. So the perimeter of your rectangle is 38 centimeters. So that's why expressions are useful, and that's why we use them. Yeah, perfect. Cool, okay. Right, let's get another one. Okay. So we'll move on now to formulae. Now formulae, this section will take a little bit longer because there's a bit more that we can do with it. So the things that we can do is we can either plug in values, which I'll go through, or we can do changing the subject. So if you've got some formula and we want to find out a different bit. Okay, people have just asked a couple of questions. People are asking, by the way, why they can't see the chat. Everything is sending to me. It's just being sent to panelists, not the whole chat. So someone's asked, what if x is negative? it wouldn't be for a length. I mean, we could have what if x is negative in this expression. So say someone says, oh, x is -1. I mean, first of all, I'd say you're a liar because you can't have a rectangle with length -1. But we could just plug it into here nonetheless and find out, well, if you did have a rectangle with length -1, you'd have a perimeter of -4 -6, which is -10 centimeters. So obviously that doesn't make sense. And somebody else has asked, 4 times a number plus 5 times the same number. Write an expression for that. So I'll just write that one out quickly, just because someone's got a question. So it was 4 times number, let's grab it up again, 4 times a number plus 5 times the same number. And we want to write an expression for that. So this is a good example actually, because sometimes we have to come up with the letters ourselves. We're not actually told that anything is n or x or anything. Let's call our number something. I'm going to call it m for Molly. So 4 times a number plus 5 times the same number. Well, 4 times m, we can just write as 4m. So the thing with expressions is you can kind of form them as you're reading. So 4 times a number plus 5 times the same number. That's also m. And now we have 4m plus 5m, which is 9m. So that's our expression, is 9 times the number. So hopefully that will make sense now. Yeah, fab, everyone's getting behind that, perfect. Cool. Now we'll go on to some formula stuff. If you have any more expression questions, whack it in the chat or the Q&A and we'll come back to them at the end. So we'll start off by, I think I've written some down, yeah. We'll start off by doing some substitution into a formula. So, for example, we have the equation v equals u plus at. And our question is, what is v when u equals 2, a equals 9, and t equals 5? And all we do here, this is a nice kind of question because we're just substituting the stuff in. So we're going to do v equals, well, our u, which is 2, plus a, which is 9, times t, which is 5. And then we have to do BIDMAS, BODMAS, whatever you want to call it. So the 9 times 5 first. So this will v equals 2 plus 45. So v equals 47. Someone's probably saying that in the chat. 47, yeah, cool, well done, guys. Nice. And similarly, we could have something like, we could have y equals x squared minus 5x plus 3. So it's quite interesting because this is technically a formula because it's not something that we can solve. But if we were to plot this on a graph, we'd call this an equation of a line. And the reason is because this bit here is an equation. And the way that we get the line is just by setting x to different values and seeing what we get for y. So for example, this is much more likely to be a graph kind of question. And it could be, what is the value of y when x equals 7? So, you know, this curve could look something like this. I don't know where I would cross the axes without working it out. But what we're then saying is that when x is equal to, say, 7, whether that, maybe that's here, what's our y going to be equal to? That's what this is saying. So the way that we work this out is we substitute in x being 7. So we say y equals 7 squared. So whenever you see an x, you put in, oh, I didn't even write when x equals 7. Whenever you see an x, you put a 7 in its place. So y equals 7 squared minus 5 times 7 plus 3. So y equals 49 minus 35 plus 3. So y equals 17. I'm just going to check that other people have got that because there we go, 17. I've said it before, my mental maths is not as good as it should be for a tutor. Cool. If anyone, someone said they have a formula question, just send it. That's fine. Someone said, would this be an exam? It definitely could be, especially in terms of a graph saying, here's a formula, what do you get when you put these things into it? Someone said, don't use BODMAS. So yeah, so I did for this. So I worked out my indices first. That's or the order. What that means is the power. So I worked out this first, giving me 49. Then I did the multiplication. And then I did the subtraction and addition. Cool. So hopefully that will make sense. That is just substituting things in. So now we're going to go over rearranging, which is a bit more difficult. Unless anyone. Question. Someone said a good question. What if the question said find the value of x when y is 0? That would be quite a difficult question, but we would do exactly the same thing. And we would set our y equal to 0. So I'm just going to write y on the other side. X squared minus 5x plus 3 equals 0. Now, this one doesn't factorize. I could have been smart and anticipated this question and chose one that factorized, but I didn't. So you would either factorize this like we've done in previous sessions or use the quadratic formula. Another example of a formula where you plug things in and get a result. So, yeah. Someone said, wouldn't you do the 35 plus 3? Good question. No. With BODMAS, let me write this out because this is a really good point, actually. With BODMAS, you do the brackets first, then you do the order, then you do any division and multiplication, and then you do any addition and subtraction. Now, here it's kind of where the order matters. If we did the 35 plus 3 first, we'd be putting in some brackets here that don't exist. And what we'd essentially be doing is 49 minus 35 minus 3. We'd be subtracting both bits, which we don't want to do. So you don't actually have to do it in the order addition, subtraction. All it means is that it's addition and subtraction next. So we're actually going to do this in the linear order that it is written. Hopefully that makes sense. Someone else said something as well. Let me just answer that question because it was a quick one. Is this foundation or higher or both? Both, probably. Questions just saying substitute this in is much more like foundation. But one saying, especially this one, what is x when y is 0? That is more of a higher question because you'd have to do factorization or completing the square or quadratic formula. So we're going to move on to rearranging now. If you've got any questions about that, I'll come back to them at the end. So rearranging or changing the subject is basically when we have a formula. For example, say you have the cosine rule, where you've got it in terms of, so it's a squared equals a load of stuff. And say you want to find what the angle is. So maybe if you haven't done the cosine rule, I'll do it with Pythagoras, right? So in Pythagoras, we're doing a squared plus b squared equals c squared, which is great if you want to find out c squared, if you want to find out the length of the hypotenuse, great. What if we don't? What if we have the length of the hypotenuse and we want to find out the length of one of the other sides? Well, then we're going to rearrange it. So let's label these sides. It doesn't matter which way around A and B go, as long as the hypotenuse is C. So we want to rearrange for A, make A the subject. So we're going to say a squared equals c squared minus b squared. And that you've probably done. If you've used Pythagoras, you've kind of got familiar with that, doing the hypotenuse squared minus the other side squared. Or if we want to be really specific about it, a is equal to the root of that. So changing the subject is probably something that you've done quite a bit before. Someone said, why wouldn't you use SOHCAHTOA for this? Because we're not interested in an angle. SOHCAHTOA is only when we're interested in an angle. So I've got some changing the subject questions that I'll go through. I'll try to do these a bit slower because I know that they can be difficult. I've got some extension questions as well, some harder ones for those doing higher or in year 11 or something. So for example. That is awful writing, I apologise. Make P the subject, so that just means write it in the form P equals something, of 3P plus 2 equals AB. So obviously this is currently in the form where nothing's really the subject, but we want to make this P equals. Now this is an okay one because we can kind of see what to do, hopefully. So first of all, we'll start by subtracting 2 from both sides. So we get 3P equals AB minus 2. And then we want to divide both sides by 3. When in doubt, think about what's currently being done to P and reverse it. So P is currently being multiplied by 3. We don't want that. We want to get rid of the 3. So we're going to reverse it and divide by 3. So we have P equals AB minus 2 over 3. Hopefully that makes sense with that one. Yeah, perfect. People got that really well. Nice. Well done. Okay, let's have a go at another one. So let's say we want to make R the subject of 3B over R equals S squared. So with this one, it's a bit trickier because we're going to have to do a couple of steps because there's nothing that we can do in one step to just get rid of the 3B because the R is currently on the bottom of the fraction. So what we're going to do first of all is try to pop that R up to the top so that we can get it by itself. So to do that, because it's currently being divided, we're going to multiply both sides by R. So we get 3B equals S squared R. So S squared times R. And now, because we want R equals something, it totally doesn't matter which side R is on, but it's always nicer, kind of nicer for you, nicer for the examiner if R is on the left. So all I'm going to do here, I'm actually going to write it in grey because it's not a very significant step. I'm just changing the way around that I'm writing it. I'm just putting S squared R on the left and 3B on the right. And now we can see that all we need to do to get R by itself is divide by S squared. So R equals 3B over S squared. So sometimes you might get a question that says, you're given this, and it might say, what is R when B is 3 and S is 4 or something? And then you have to rearrange to make it R equals, and then you can put the numbers in. So that's more like a higher question, changing the subject and doing some formula substitution. Someone said, shouldn't it be minus when it's going to the other side of the equal sign? I think you're talking about when I did this step. So if we're talking about this step, it's because I've just multiplied it, so it doesn't need to be negative. I'm not adding or subtracting anything, I'm just multiplying. If you're talking about this step, all I'm doing is rewriting the way around that I've written it. It's like saying if A equals B, then B equals A. That's all I'm doing. I'm just writing around, switching around the way that I'm writing it. If you want to think about it in terms of negatives, I'm kind of subtracting this one from this side and this one from this side. So they're both negative, so it's not there. That's probably more confusing. It's probably best to just think about it. A lot of people are saying, why can't they see the chat? Why can't they talk to the other students? I don't know if it's because the way that the meeting is set up, but above where you type your message where it says 2, if you click on that and change it to say send chat to all panelists, not all panelists, sorry, all panelists and attendees, just see if that works. If not, don't worry. Other people don't need to see what you're saying. Cool. We'll go for another rearranging question. So let's say make Q the subject of 4 root Q equals 12A. So this one is going to be really similar to other ones. One thing that we can actually do here is, so we want to start by dividing by 4. And lucky for us, whoever wrote this formula didn't do a great job because they could have simplified it like this to start with. And they could have said that root Q is equal to 3A. Because 12A divided by 4, well, it's just like saying 12 divided by 4 and sticking the A on the end, so it's 3A. And then Well, how do we get rid of a square root? We do the opposite. So we square it. So we square both sides. Now we've got to be careful with this. When we square this, we get q. When we square 3a, we get all of 3a squared, which means we have to square each individual bit. So we get 9a squared. So that one's a bit sneaky because you've got to be careful what you're doing there. Oh, okay, people says it's not working on the chat. Don't worry.
Yeah, I'll just jump in quickly. Yeah, just for now, we're just having the chat function switched off, but Molly can still see all your questions, and we'll review that at the end of the webinar. Cool,
thank you. Yeah, I can still see everything, so don't worry about messaging other people. So one second, we go back quickly to that one. Cool. So hopefully all of those ones make sense. That squared one was a little bit tricky because you had to do all of the 3a squared and really keep an eye out for that. So now we're going to do some slightly more advanced ones. So what I'm going to do is I'm going to put one on here and just give you 30 seconds or so to see if you come up with any ideas about how we can do it. So we want to make x the subject of ax plus c equals bx minus d. So we want to make x the subject of that. So I'll just give you 30 seconds. Feel free to whack it in the chat. Cool. So some people are coming up with some ideas, which is good. Yeah, cool. Some people are getting the right idea. Awesome. So some people are saying to write it in the form of like x equals and then something in terms of x. That's not quite right, because if you think about if we're given then A, B, and C, A, B, C, and D, we still wouldn't be able to work out x because we'd have x in terms of x and we don't know x. Does that make sense? I've said x too much, it doesn't sound like a word. So what's really good that a couple of you says is that we want to factorize x. So I'll show you what I mean. We're going to move all the x's to one side and everything that's not an x to the other. So we're going to move ax and bx basically because they're just the coefficients to the left. So we'll have ax minus bx plus c equals minus d. And then we'll move that c to the other side as well. So ax minus bx equals minus c minus d. So we've got everything that's got an x in it on the left, everything that doesn't have an x in it on the right. And now to get x by itself, we're going to take out a factor of x. So we're going to say that this is equal to x lots of a minus b equals minus c minus d. And then, well, we can just divide now by a minus b, because we've got factorizing it has enabled us to get x by itself. So we can say that x equals minus c minus d over a minus b. And we can actually make this a little bit, look a bit nicer as well. This is a more, an advanced step again. We can say that x is equal to minus c plus d. This is basically just because mathematicians don't love negatives because they can get lost in the equation. We prefer to keep as much positive as possible. So we can say that this is minus c plus d over minus b minus a. Hopefully you can see where that's come from. So here I've just kind of factorized out a minus, and here I factorized out a minus because this gives us minus b and plus a. Don't worry if you don't follow this step. This one isn't crucial. The rearranging, this just makes it look a lot nicer. And then we can like divide, basically cancel out the negatives because it's a negative divided by a negative, like divide both the top and the bottom by -1, and x is c plus d over b minus a. So this form I just think looks a lot nicer. You've only got one negative rather than 3 there. So I'll just check the chat to make sure that people are understanding this. Someone said, is it still okay to have it as it was? Yeah, that's absolutely fine. Unless it explicitly says, which I don't think it would. This is just because if I then went on to use it, I'd be worried that I'd miss one of the negatives, accidentally do just C minus D or something. So this just helps me. You wouldn't lose any marks. Yeah, I'll do another one of this type. Yeah, people have asked for that. That's absolutely fine. Someone's asked, what is 0 divided by 0? That's one that you can Google. It's quite interesting if you want to look. So we'll do again. Let's make x the subject of 6y equals 3x minus 7 divided by x. So again, we've got x in a couple of places here. So I'll just give you a minute to have a look at that yourselves and have a go, and then I'll walk through it. Oh, someone said, what is 0 to the power of 0? I remember running up to my maths teacher and asking her this. The answer is some people think it's 0, some people think it's undefined, some people think it's 1. It's an interesting one to Google as well. Honestly, don't tempt me because I love stuff like this. So, but it's not the topic today. So have a go at this. Cool. So I'll go through this now. Don't worry if you haven't had a chance to go through it. I just don't want to waste your time by just sitting here while you're doing it. So the first thing that we want to do is get rid of this x from the bottom, basically. So the way that we get rid of stuff from the bottom of fractions is by multiplying up by it, because it's currently being divided by x. So we're going to multiply by x. So that means that we get 6y times x. I'm going to write it as, no, I'll keep it as 6yx actually. 6yx equals 3x minus 7. And now this looks more like what we had before. We've got two linear terms of x, nothing divided. No, we've got two, I don't mean linear, what do I mean? Nothing divided, no fractions basically. So we'll move that 3x to the left-hand side. 6yx minus 3x equals minus 7. And then we'll take out that factor of x. That's the key one with these rearranging. So x lots of 6y minus 3 equals minus 7. Hopefully you can see where I got that from. So just taking x out of both of these. So we're left with 6y here and we're left with minus 3 here. And then we just divide by that. So x is equal to minus 7 divided by 6y minus 3. And now, again, just as a challenge, if anybody wants to do this, that is a totally fine thing to leave it in. I'll just write it in a grey colour. This is also going to be equal to 7 over 3 minus 6y. I think that's a nicer form because you don't have a negative number on the top. Feel free to play around with it yourself and work out why that is. Minus 7 over 6y minus 3. Yeah, a lot of people got that. Well done. Well done, guys. Cool. So what time are we on? Okay, we're technically in the last 15 minutes. That is more stuff that I could go over, but to be honest, not much. So I'll open it up to questions. Yeah, because I think we've gone over a lot of stuff here.
Fab, there are just a couple of questions that have come up a few times, and I think a couple of them you have answered, but then people asked again, so I'll just ask for a bit of clarification. So this was earlier on in the tutorial. What year group do you learn this content and topic in? I think that was near the beginning, just going over expressions. Does that fall into a particular
okay. It depends completely on, firstly, the school, especially if it's Key Stage 3. Secondly, the exam board that you're doing. I'd say learning the difference between expressions, formulae and equations is probably a Key Stage 3 topic, maybe 8 or 9, maybe 8. Yeah, around then.
Fab. Okay, cool. Thanks, Molly. I think this was a question that got asked a couple of times about the last question. It was, when you first get a question and there's multiple letters, what letter do you decide to start with? I don't know if it makes sense in the context of the last question.
Of which one? Oh, I can see the question. When number or letter do you decide to start with? What, as in one like this?
Essentially.
I'm not 100% sure. Do you maybe mean in terms of like rearranging? It's just like what they give you. They'll say do it, make X the subject. They'll like tell you what to make the subject. Feel free to clarify that question and I'll come back to it.
Yeah, brilliant. Fantastic. And someone just asked, why did you switch around the 6y minus 3? I assume that was on the last question.
Oh, okay. On this one. Yeah, sure. I can go through this. Yeah, like I said, this one is a bit more advanced and it's totally fine to leave it in that first form. But I'll just show you what I did. So I basically took out a factor of -1 again. So we had -7 over 6y minus 3, which we can express as minus, and I'll write it this way around actually for now, minus 6y plus 3. And that's because minus 6y is plus 6y and minus plus 3 is minus 3. So what I've done is I've extracted a multiple of -1 out of there. And then these negatives cancel. I've basically divided everything by -1. And then this becomes 7 over minus 6y plus 3. And then I've just swapped them around on the bottom because we can do that. Minus b plus a is the same as a minus b. And I just prefer it that way around. So 7 over 3 minus 6y. That was just to make the solution look nicer. That's not necessary. It's just a bit of extra if you wanted to, do a bit more advanced.
Fab. A few people are asking for you to go through one more similar to the last question. Would you be able to do that quickly?
Yeah, sure. I can go through one like that. Cool. I will try to make up a hard one because those are the only ones I had written down. So I'm going to go for, okay, 6. Gosh, right. I've got to make sure that this works. Okay, 6x minus 2p over x equals, I'm going to have another letter in here as well, y. In fact, I'm going to make this 6x minus 2px, go a bit crazy with all of the x's, equals y plus 3p minus 5. There we go. A horrible question. And let's say that the question for this is make x the subject. So again, we want to get, now here, I guess all of the x's, oh wait, have I made this question really stupid? No, that's fine. It will work. All of the x's kind of are on that side. Oh wait, no, this will work. No, this isn't what I want to do. I'm going to leave that as 2p. We'll make it y plus p minus 5. I could have cancelled that x there. That's why I changed the question. So all of the x's kind of are on that left-hand side, but we're wanting to like move this p over to this side, basically. Sorry if you'd written that out and I just changed it. So we're going to do what we did before and multiply up by x. So we get 6x minus 2p equals, now here, everything on that side gets times by x. I'll do it in 2 stages actually to make it even clearer because it's x lots of everything on this side. So that means 6x minus 2p equals yx plus px minus 5x. Everything that x is being expanded out by. And then we take all of that over to the other side and the 2p to that side. So we get 6x minus yx minus px plus 5x equals 2p. I did a couple of things in one there. So I subtracted the yx, subtracted the px, added the 5x, and simultaneously added the 2p to this side. And then we're going to factorize the x. There's just a bit more in the brackets this time. So this is x lots of 6 minus y minus p plus 5 equals 2p. And actually, look here in the brackets, we've got a 6 plus 5, so we can simplify this a bit, which we love. So x lots of 11 minus y minus p equals 2p. Just added that 6 and the 5. And then finally, divide by this that we have in the brackets. So x equals 2p divided by 11 minus y minus p. And that's the solution to that one.
Brilliant. Okay. If anyone has any questions on that or any last questions, just pop them in the chat. I'll just answer a couple of more logistical questions that have come up during the session. So people asking where they can see the other sessions that are running and what other sessions we're doing this week. So if you missed that at the beginning, every day this week we're doing Maths GCSE sessions at 12:15 with Molly, and then also Physics GCSE later in the day at 2 p.m. With another of our brilliant tutors. So if you want to join us for that, then please do. You can also see a timetable for all of this on the online school page, and all past tutorials are on our My Tutor YouTube channel. So if you wanted to watch back any of those, then please feel free to do so. And yeah, if you have any questions, just pop them in the Q&A for the last couple of minutes. Some people are sort of asking and have been asking about other similar topics or related topics and when we'll go through them. We're keeping an eye on the topics that you guys are asking for and are keen to do, and sort of planning our schedules based on that. So you can see on the timetable the few that we have for the rest of the week, but we'll make sure to try and cover everything relevant, and we're working to make sure that we're covering the things that you guys are interested in. So there's been mentions of graphs, other sort of parts of algebra. So thank you for all those suggestions. We're definitely taking those on board. I think, let's have a look. And yeah, there will be some other sessions on different subjects. So we're doing Physics GCSE this week, but next week we'll also be looking to start some biology and chemistry as well. So you'll find out about that via email, and you can also see the timetable as well, which is on the My Tutor online site. So let's have a look. We've got a few more minutes. Molly, do you want to wrap up with another question similar to the last one?
Yeah, sure. I'll do one more like this. I think people are finding these ones useful. Yeah. So I'll do another like this. Cool. So we'll do another great. Molly comes up with one on the spot. Right. Let's go for 7 minus 2x plus y equals over x over, you know what, let's go crazy, over 3x equals 5 minus y. So let's go for this. So here we can see that it's going to be similar to before. We're going to start by multiplying up by the 3x. Generally, if you've got some, again, sorry, this is making x the subject. So if you've got something in the bottom that you want as the subject, we're going to multiply up by it. So we'll start off by doing that. So we get 7 minus 2x plus y equals, I'll do it in 2 stages again, 3x times all of that. And that means that we get 15x minus 3xy. It doesn't matter, I could have written 3yx as well. I think this just makes more sense because we're keeping the 3x together, but they're all multiplied, so it doesn't matter at all. Then we want to get everything with an x in it on the left-hand side. So I'll do that first. I won't try to cut corners with this one. So 7 minus 2x plus y. Well, now everything there is going to be on the left-hand side because it's got an x. So we subtract that 15x and we add that 3xy. Oops. And now we've got nothing on this side, but we want to send over the 7 and the y because otherwise we've got nothing. So we'll end up with minus 2x minus 15x plus 3xy is equal to minus 7 minus y. Hopefully you can see there's a lot of parts to this one, so hopefully you can see where those came from. We're just taking this 7 and this y and subtracting them to work them over to this side here. Then we will take out a factor of x. So we're left with minus 2 minus 15 plus 3y. And the side stays the same. So hopefully you can see where this came from. We've got minus 2 here when we take out the x. When we take out the x, we have minus 15 here. When we take out the x, we're left with 3y here. Similarly to before, we've actually got a minus 2 minus 15 now, so we can make this a bit nicer for ourselves by combining those to make it minus 17. Then we're going to, I guess, the final step, but I will show you I've got time to show you the bit with fractions again. So x equals minus 7 minus y over minus 17 plus 3y. So that is our solution. I'm just going to quickly show you that little advanced bit of getting rid of some of those negatives. So again, do not worry if you are confused by this, especially if you're Key Stage 3 or doing foundation. But it is good to try to understand, because it's not too bad. I think it just seems overwhelming to start with. So what we're going to do is we're going to take out this factor of a negative. So we get 7 plus y, because that's minus 7 minus y. And pop that over this with the negative taken out. So that's 17 minus 3y, because we've got minus 17 and a plus 3y. So then if we remember, these bits cancel out, and wahey, we get 7 plus y over 17 minus 3y, which looks a lot nicer. The other way that you can think about it, the kind of cheat way, is that we make every minus a plus and every plus a minus. That's essentially what we've done here. So this becomes plus 7, this becomes plus y, this becomes plus 17, and this becomes minus 3y. It's good to know why that happens, but you can just think about it like that. Yeah, and that brings us to the end.
Brilliant, thanks Molly. I think that one was really valuable. Just to reiterate, yes, this week is just maths and physics. Starting next week we'll have some other subjects as well, but just watch this space. We'll be updating you as and when those are added. So thank you so much for another great session, Molly. Thanks to everyone for joining, and hopefully see you in another session soon. Bye.
Yeah, bye everybody. Thank you for coming.